In this video, we're going to compare the difference between weight and mass. Here I have a 1 kilogram mass. When I bring this 1 kilogram mass, right now it's on Earth. If I bring it to the moon, it will still be 1 kilogram. If I take it to space, it will still be 1 kilogram. Now let's say I put it on a scale and we are on Earth. If I put it on a scale, this scale can measure the weight of this 1 kilogram mass. And the weight I will get for this 1 kilogram mass is 9.8 newtons. On the moon, if I take the same 1 kilogram mass and I take it to the moon and I weigh it on the scale, I would get only 1.6 newtons. If I were to do the same thing in space and put it on a scale, I would get 0 newtons. Okay. So what is the difference between weight and mass? So let's define mass first. So mass is the amount of matter in an object. And we measure mass in kilograms. Okay, so whether the mass is on Earth or on the moon or in space, it has the same amount of matter. You can think of it as the amount of stuff in an atom, as in an object, or the amount of atoms, the kind of atoms or molecules in an object, because those don't change. Whatever matter is in the object on Earth, it's going to have the same amount of matter on the moon and in space. So the mass does not change when you take it from one location to another location. However, weight does change depending on your location. And weight is the force of gravity. And it's measured in newtons. And by the way, mass is a scalar, which means it only has a magnitude, while weight is a vector. It's got a magnitude and a direction. Now, oftentimes students will get mass and volume mixed up. So let's go ahead and define volume as well. So volume is the amount of space an object takes up. And we're going to take a look at some examples of that in just a moment, where we're going to compare the weight of some things and things that have large and small volumes compared to things that have large and small masses. So we'll take a look at that in just a moment. But right now, let's go ahead and go back to this idea of weight. So weight is related to the mass in that weight is equal to the mass times the gravitational field strength. Okay, so we can shorten this by writing it using abbreviations. The weight is equal to the mass m times g. Okay, and g on Earth is 9.8 newtons per kilogram. So that's on Earth. And g is about 1.6 newtons per kilogram on the moon. Okay, so what this is telling us is that for every kilogram of mass on Earth, it will weigh 9.8 newtons. On the moon, because the gravitational field there is different, for every kilogram you have on the moon, it's going to weigh 1.6 newtons. So if you know the gravitational field strength, which is this number right here, and you plug that in, then you take the mass times that number, that will give you the weight for that location. Now let's take a look at some items and let's compare their mass and volume. So I'm going to create a little chart here. In the top left, I'm going to write an item that has a small mass, okay, and a small volume, okay? Can you think of something that has a small mass and a small volume? An example of that would be grains of sand, okay? So a grain grain of sand. That would be an example of something that has a small mass and a small volume. And so as I go through this, I want you to think about how mass and volume are different. Now let's think about something that has a small mass, but a large volume. Okay? An example of that would be a balloon filled with air. Okay, so here's my balloon filled with air. So it's got a small mass, but it has a large volume. Okay. Now let's take a look at an object that has a large mass and a small volume. Okay, so an example of that could be a steel ball. So a steel ball. So here's my steel ball. Okay, my steel ball. So a large mass, but a small volume. And finally, we're going to look at an object that has a large mass and a large volume, okay? So this could be like a large water container, okay? Maybe a barrel of some sort, okay? So this is a large water barrel. Go ahead and put that there. So a water barrel.